this is multiplying and dividing, but before I move on to that, I did get cut off a little bit in my previous video. Those last two problems where you're factoring, I'm not going to work through these, but you can check your work. Essentially, what you need to do to verify your domain is to factor the denominator. You can factor the numerator, but it's not going to give you information as far as what the restrictions on your domain are. So just check your answers on that quickly. And now we are going to move on to multiplying and dividing. So multiplying and dividing, again, rational expressions are fractions. They're just fractions that still have polynomials in our numerator and our denominator. So we multiply and divide them the same way we do with fractions. So you multiply your numerators, you multiply your denominators, and you cancel like terms. So again, you really need to be comfortable with factoring. If you're not, there is a practice assignment in Delta Math to refresh yourself on those skills. But let's get started on a couple examples. Multiplying. Let's multiply these expressions. So again, you're going to simplify each expression, then you're going to multiply the top and the bottom and simplify further if possible. So I'm going to start on A. I'm just going to simplify this first expression first. So 4 over 3, nothing in common that I can cancel, but I have x to the third over x to the first power. So I can simplify that and get x squared in the top, and that y to the fourth stays in the bottom. Okay. Now let's look at our second expression. Negative 6 over 10, they have a common factor of 2, so I can simplify that to be negative 3 over 5. Then x squared over x to the fourth, that gives me x squared in the denominator, and y squared. So now I'm going to multiply across the top. 4 times negative 3 is negative 12. X squared y squared over 15 x squared y to the fourth. Now, I have x squared and x squared, so that cancels. And then x squared over, y squared over y to the fourth, that's going to give me y squared in the denominator. And then additionally, negative 12 over 15, those have a common factor of 3, so that's going to give me negative 4 over 5 y squared. Okay. Now, on to B, where we have some addition and subtraction going on. What I'm going to do is factor everything, and then we can multiply across and cancel our like terms. So in my numerator, I have a binomial, which means I'm going to take out the GCF, and that's going to be 4x, and that leaves us with x minus 1. In my denominator, I have a trinomial, so I'm looking for factors of negative 3 that add to positive 2. That's going to be positive 3 and negative 1. On my other rational expression, I've got a trinomial. So I'm looking for factors of negative 6 that add to positive 1, and that's going to be positive 3 and negative 2. And then in the bottom I have a monomial, so that is going to stay the same. I cannot factor it. So in my first expression, I have x minus 1, again, stuck inside those parentheses. It's protected, it's being multiplied, so that reduces. So I've got 4x over x plus 3. And then multiplying across the top, x plus 3, x minus 2 over 4x. What else can I simplify? I have a 4x and a 4x, and I have an x plus 2 and an x plus 2. So my final simplified expression is x minus 2. Okay. Let's keep going. X plus 3 over x minus 2 times 5x. Remember, if it doesn't have a denominator, we can assume that it is 1. So this is times 5x over 1. I have nothing that I can simplify in either of these terms, so we're just going to multiply it across the top and multiply across the bottom. And there is nothing we can simplify. This is the final expression. Now D, again, we're multiplying 3 expressions here, but again, you're just going to multiply all 3 in the top and all 3 in the bottom. So let's start simplifying and make life a little bit easier for ourselves. Trinomial, factors of positive 2 that add to negative 3, that's going to be negative 2, negative 1. Can't simplify x plus 2. 3x doesn't simplify, neither does x minus 2. Now, binomial, I can take out a GCF. And again, binomial, take out the GCF. Now, essentially, this is all being multiplied already, so you can kind of skip this step we did on B and just go across the top and the bottom and cancel your like terms. So x minus 2, x minus 2. X plus 2, x plus 2. And now I've got, what else do we have? At top, I'm going to have this x minus 1 times 3x times 2, which is 6x, over x times x minus 5. Now, you may have already recognized this next thing we can cancel before we move down to this step, and if so, that's great. But I have an x and an x here. So that can also cancel. And I'm just going to move the 6 to the front. So 6, x minus 1 over x minus 5 is our final simplified rational expression. So again, everything here is factoring and simplifying. So when you're multiplying, there's just more things that you can cancel in your top and bottom. Okay. Now, dividing is we divide rational expressions the same way that we divide fractions. So if I was going to divide 1/2 by 2/3, keep, change, flip. First fraction stays the same. This becomes multiplication, and you flip your second fraction, and then you multiply top and bottom. It's the same thing for our rational expressions. You're going to flip the other second expression and multiply. So again, we are factoring. We are canceling like terms and simplifying. So it's not that much harder than everything else we've been doing up to this point. Let's see this in action. Starting on E, keep, change, flip. Okay. X over x plus 3 is going to be multiplied by x minus 1 over 4. Now, I have nothing that I can factor here and nothing that I can simplify. So this one is going to remain just the product of these two expressions. Now, you could distribute out and that's fine, but again, you're not accomplishing anything. There's nothing more you're going to simplify by doing that. You're just giving yourself extra work. This would be a completely satisfactory way to leave your answer on a test, as long as there are no common factors in your numerator and denominator. But what happens when there is stuff that we can factor? On F, again, dividing rational expressions, we are going to keep the first one the same, change our operation to multiplication, and flip upside down our other expression, and I apologize if you can hear my daughter in the other room. Okay, so now we are multiplying these two expressions. We need to factor and simplify. So on the first one, can't simplify in the top, GCF in the bottom, times, this is a trinomial. I'm looking for factors of positive 8 that add to negative 6. And that is going to be negative 4 and negative 2. And then in my denominator here, we take out a GCF. All right. Now, let's cancel. X minus 2, x minus 2, x minus 4, x minus 4, x, and x. So this one is actually going to leave us with 2 over 3. Practice some more. On G, keep, change, flip. That one's going to stay the same. I'm going to multiply, flip this fraction upside down. Sorry, not fraction, rational expression, which is a special type of fraction. Okay, now let's factor. Difference of squares, hope you recognize that one. Times. Looking for factors of negative 35 that add to positive 2. It's going to be positive 7 minus 5. GCF. All right. We factored everything. Let's cancel our like terms. X minus 7, x minus 7, x minus 7, x minus 7, x plus 7, x plus 7, and that leaves us with a final expression of x minus 5 over Last one. This is another way that you might see a rational expression being divided. So this is rational expression, rational expression. This is the same thing as x minus 1 over 5 divided by x plus 3 over x, right? Fraction means division. So keep, change, flip. And this one's kind of similar to E that we've already done, but I can't simplify anything, can't cancel anything. So this is just going to be the product of these two expressions, and that's the final answer for H.